1-1. Hello and welcome to the 2024 BRICO Steel Bridge Building Competition. We are thrilled to have you here to join us for this exciting event, where the engineering and design get together. To kick off the event, I am honored to invite to the stage the Dean of the School of Engineering to deliver us the opening speech. Please welcome Fyodor Sergeyev.
Aitäh! Ja ma proovin rääkida mõlemas keeles, peaaegu samaaegselt, nii et need, kes ei valda eesti keelt, siis oodake natuke. I will try to speak in both languages, so don't worry, I will translate the things in English also. Tere tulemast! Tere tulemast Tallinna Tehnikaülikooli inseneriteaduskonda, ma isegi näen, et siin on teaduskonna logo on siin ja ma arvan, et ma olen ka õige inimene, et teha avasõnad just terassildade ehitamise võistluse jaoks, sest mina olen oma teadusliku suuna ja õpetamises valdkonna spetsiifika järgi metallide tehnoloogia professor. Ehk teras ja kõik metallide tehnoloogiatega seotud asjad on mulle väga-väga südamelähedased. Welcome to the Tallinn University of Technology and the School of Engineering. And I think I'm a really good person to have an opening speech here because by my professional side of teaching and research, I'm a professor of metals processing. So the steel bridge building is very close to me through the metal processing technologies I'm involved every day. Sillad. Kui mõelda, mis asjad need on? See ei ole lihtsalt konstruktsioon ja ma proovisin ka vaadata ajalugu. Ajaloost on igasugust infot, kahjuks eesti keeles on väga vähe infot, aga sellised peamised mõtted, mis on leitavad internetis sildade kohta, on see, et nad on erinevate konstruktsioonidega, jällegi erinevates materjalid tehtud, kõige vanem sild, kõige pikem ja nii edasi. Aga see ei ole isegi oluline, vaid on oluline üldine põhimõte, mis asi on see sild on. Sild on tegelikult asi, mis ühendab eelkõige inimesi. Eelkõige selleks, et me saaksime koos elada, liikuda, jällegi sildade kaudu siis käia üksteisel külas ja see on see kõige olulisem asi. Ja seepärast mul on väga hea meel tõesti ka tõdeda seda, et meil on rahvusvaheline võistlus, et siin on ka erinevate riikide esindajad ja teine väga oluline asi on ka see, et täna ja järgmistel päevadel võistlusel osalevad mitte ainult üliõpilased, vaid ka gümnasistid. What are the bridges? I was trying just to find some information in the internet, just general information about the history of the bridges and the main things you can find very easily, but not enough of information in Estonian, unfortunately. But the general information is that the bridges are the constructions made from many variety of different materials, steels, wood, and etc. With different constructions, different types of bridges, and you can find information about the longest bridge, the oldest bridge, and etc. But I couldn't find the major information and the most important information, because the bridges are constructions to connect people. to make it possible for people to move together, to just pass some routes together and make the things together. And this is the main function of the bridges, which is very important. And I'm very glad that we are here for a bridge construction contest, and I'm really glad that we have international format, having people not from only Estonia, but also I'm very glad that we have different kinds of contestants. We have both students of the universities, but also gymnasium students, so it's very good. Ma samuti proovisin küsida ka tehisintellektilt, mis asi on BRICO? Kas te olete proovinud? Huvi pärast, miks? See on ju täitsa tänapäeval tavaline asi, on ju tehisintellekti käes küsitakse, mis iganes asja. Ja just tõesti 15 minutit tagasi toppisin ChatGPT 4 akna sisse küsimuse. BRICO võistlus, kõik, küsimärk, 2 sõna. Tuli ilusasti küll väga lühike vastus, aga tuli väga õige info, et see on terasildade ehitamise võistlus, mis toimub nüüd 24 aastal Tallinnas kuupäevadel, õigetel kuupäevadel, kogu see info oli õige. Ja mis oli ka hea, seesama info, et osalejate hulgas on ka gümnasistid, oli seal täiesti ka välja toodud. Aga see oli ka kõik. Et selles mõttes info võiks olla ka põhjalikum ja vastused ka sellistele lihtsatele küsimustele ka paremad. Mis ma hakkasin mõtlema? Ma hakkasin mõtlema ka selle peale, et ma juba alustasin sellest, et teras on väga mulle lähedane, südame lähedane materjal, aga eks me kuuleme tänapäeval rohkem ja rohkem mõtteid selle kohta, et me peame olema kestlikumad ehk rohelisemad, on ju, kõik asjad peaksid olema rohelised ja kestlikumad ja sellised suuremad ehitusvaldkonna suuremad uudised on siin viimasel ajal olnud uudised täis puidukonstruktsioonides kõrghoonete ehitamisest Eestis, et alustatakse esimese hoone ehitamist ja siis on juba teiste selliste puitkonstruktsioonide tagasitulek meil on alguses saanud. Ja ma hakkasin mõtlema, et äkki siin BRICO-l ka peaks tekkima ka selle alamharu võistlusest ja ka teistest materjalidest puidus näiteks hildade ehitamise võistlus, aga see on võib-olla arengu mõtted edaspidiseks. Aga ikkagi, miks ma seda ütlen, on seesama kestlikkus. Ja minu meelest teras on väga roheline materjal. Teras on väga roheline materjal, sest seda saab ümber töödelda väga lihtsasti, ümber sulatada, uuesti kasutada ja nii edasi. Ja kaod on kõik väga väiksed. Et seepärast ma siin rõhutan ka näha, et teie tegevused on ka rohelised. Teie tegelete praegu ka kestlike tehnoloogiate arenguga, mis on väga hea. Just 10 minutes ago, I asked from artificial intelligence, what is a BRICO? I just typed into ChatGPT's a question, BRICO contact. What is it? Just 2 words, and the answer was correct, but too short for me. The answer was that the BRICO contest will happen in Tallinn in a date, were correct data for this year, and also was mentioning the participation of gymnasium students, but that's it. And that's too short answer for me. Why? Because there are a lot of new developments in construction in civil engineering, and a lot of them are related to the green transition, Green Deal. We should be using more sustainable technologies all the time, and at least in Estonia, there are a lot of news about starting to build high buildings from wood, having full wood constructions. 6 and 8 floors high buildings, for example, which is very good. I started also to think maybe here we're talking about steel bridges. Maybe we should also think in the future about some different materials, wood as an example, but this is a different story. But still, why I'm talking about this, I want to emphasize that the steel itself is a very sustainable material. It's sustainable in a way we can reuse it many times. It's very easy to reuse it, just to melt it down and have new parts or structural units from steel made. And this is definitely a sustainable way of using of materials and technologies. And you are involved in this very good movement of sustainability, and you are also kind of ambassadors of it. Teil on ees, ilmselt on pikad päevad ja täis tegevusi päevad. Nii et palun võtke nendes päevades kõike, mida võtta saab. Kokkuvõtteks ma ikkagi rõhutaks neid 3 märksõnu. Esimene ikkagi sillad on selleks, et ühendada inimesi. Ehk proovige teha koostööd mitte ainult oma võistkondade sees, mida te kindlasti oskate teha, aga suhelge ja oma konkurentidega, aga pärast peale võistlust nad ei ole enam konkurendid. Nad on kõik teie partnerid. Teine on jätkusuutlikkus. Ikkagi mõelge ka selle peale. Küll te olete selle peale ka mõelnud, aga siin on võimalusi, et tekiksid uued mõtted, mida ka edaspidises elus ja tegevustes ka neid arendada. Ja 3. asi, olge väga aktiivsed ja tõesti ma näen, et praegu kuidagi tundub, et oled väsinud juba väsinud. See eeltöö on olnud ka pikk ja väsitav, ma saan sellest aru, aga ikkagi olge aktiivsed ja need päevad on teie jaoks. Nii et soovin teile edu. Those going to be very long and active days for you, definitely, because of the contest and all the activities during the building of the bridges. But I still want to pass main 3 messages. The first one is that bridges are still to connect the people, so try to make new connections here. New connections not only within your groups and you already cooperate, but with our competing teams. But they will be no any more competitive to you after the contest will end. So they will be your friends eventually. The second thing is sustainability. Think about it. Definitely you thought about it, but you may have new ideas how to make things more sustainable in a way that your built steel bridges will be sustainable, maybe reuse things next time, and etc. And the third thing, I can see you're very tired already. You're tired already. You're sitting just waiting, maybe, let's get on. And I understand you spend a lot of time on preparations and the things, but be active and take all the things possible to take from here, because this is your time here for bridge building. So good luck to you. Thank you.
Thank you, Dean, for those inspiring and educating messages. So, next up, we're going to meet the competing teams. Each team will give a brief introduction about themselves. First, we have a team from TalTech. TalTech teams have been strong competitors throughout the years. Let's see what they have for us in store this time. I welcome to the stage team Tallinn University.
Hello. We are a team from Talltech and we study road and bridge engineering. And we are fifth-year students now. And our team name is Tallinn University. If you think why this is 5, the Viisik, then the 5th member of our team is the bridge itself. So we started with the project in about January this year, when we started to develop our first ideas, what kind of bridge should we make. And for computations, we used Bentley Start Pro. We didn't have any knowledge how to work with that program before. We only had seen it, like our bridge engineering teacher using it. So we know that this program existed, but we didn't know how to work with it. So the first step was to learn the program, because we have learned how to make manual calculations, but it was unthinkable that we can calculate everything by hand. So we gave out to each other some visions to come up with different solutions, like some kind of arc bridges or like this bench type of bridge. And in the end, we came up with the model of something like that. It's not the final product, but it's the first version. Some pictures of our sketches, how to make the bridge work. The first phase was like a lot of brainstorming and just letting all the ideas out. And this is the final design of the bridge. The length is 5 meters and the width is 1 meter and the height is about 2 meters. So we used up all the available height that was allowed, because we wanted to have this triangular shape. It's like an arc, but it's more straight. So for the best force spreading, we wanted it to be as high as possible. So we had to cut the top off. And this is a small video of us building it. From the start, we decided that we want to make the bridge with that design that we can build it ourselves. And in this picture you can see we have 1,000 kilograms of cement on it to test it out. And this is one of our sponsors' warehouses where we got the permission to build our bridge. They had some tools, and some tools we had to bring ourselves. And the beginning was a little bit difficult because we thought that what's the hard part of building it? You just got the parts and weld them together, and it's like it's simple as that. But yeah, first I broke my collarbone before building, so that was a little bit slowing us down. But we made some forms to build the trusses, and it teaches us that forms are very important, that they need to be exactly in the right dimensions, like you can see down here. Because if it's a little bit off, then it can affect like this, that you have uneven parts. But in the end, we got it all working. We made our drawings not to like this. We made them to first design, like with most of the joints we developed during construction or thought them through. We didn't like do many calculations for them. So that's it. Thank you.
Thank you, Stelna Isik. Next, we have a team from afar. Their university's teams have been the most frequent contenders in BRICO and deliver exceptional performances every year. Please welcome to the stage from Białystok University of Technology, Poland, Team Steel Rangers.
Sorry. So we are Steel Rangers. I am Gabriela, this is Emilka, this is Dominika, and our leader, Christoph.
Hello everyone, once more time. We came to you from Białystok University of Technology. Now, as you can see, we are in our university and we are constructing our bridge and preparing for the speed contest, which will be the next day. Here is our campus of our university. This is our trip. We were driving to you for almost 10 or 11 hours. It was a little bit long journey, but we made it. We came to you on Sunday and started preparing to the contest. Now, our first stop, of course, during our journey, and the end of our journey, right before Tallinn, Tallinn University. This is the model of our bridge. We made tons of the models during preparation and during designing because we wanted to find the exact one that will be perfect in every single way. Also, we wanted to find the exact arc and the truss that will be comfortable to us to make it together, and because of it, our height of our bridge is only 1.5 meters, and it was the best height for distribution of stresses and everything connected to it. We were manufacturing our bridge in Metalfa. It is a firm, it is a company in Białystok. We were helping them during the welding process and everything connected to the manufacturing during our preparation. It is the first step, welding the arc. We started from it. Then we did the second arc, of course. When our arc was completed, we started making the deck because we had to put it together and welded it before the cutting. And the final touches. So we put it on the desk, and we had to make it together and prepare to making the connections. Now we are checking if the exact element is the right length and height to fit the whole boxes. And it is completed construction. We were preparing to painting also, and preparing to making connections, of course. It is our team and our guys that helped us a lot, and it was a fantastic experience because, you know, the designing is designing, but manufacturing is completely different way, and these guys help us a lot to make perfect connections and good bridge. We used a powder coating, and as you can see, we were choosing the right color of our bridge, right on the right photos. And these are the parts of our bridge before the painting, prepared to go to the painting room. Our sponsors, so Tallinn University of Technology, our faculty, Metalfa and Promosta. And at the end, we want to show you some short summary how to play it. That was me, and that was you.
Znajdujemy się na hali NOICOTECH na Wydziale Budownictwa i Nauk o Środowisku. Jesteśmy z Koła Naukowego SKM Konstruktor i wybieramy się na międzynarodowy konkurs mostów stalowych do Estonii, do Tallinna, BRICO 2024. Naszym zadaniem jest zaprojektowanie, a później sprefabrykowanie konstrukcji mostu o odpowiednich wymiarach podanych w regulaminie, 5 metrów rozpiętości do 2 metrów wysokości. Założeniem konkursu jest wykonanie konstrukcji, która przeniesie zadane obciążenie przez regulamin, czyli jest to 750 kg plus 250 kg przy jak najmniejszym przemieszczeniu. Musimy wykonać taki most, żeby on był jak najlżejszy, ale też jak najbardziej wytrzymały, bo po to jest. Już od kilku dni prężnie trenujemy składanie mostu na hali, dzień w dzień, rano i wieczorem, bo jedną z konkurencji jest również składanie naszej konstrukcji na czas. Mamy 20-25 minut i musimy się w tym czasie dorobić. Przy projektowaniu zakładaliśmy konstrukcję łukową, ponieważ konstrukcja łukowa w najlepszy sposób dystrybuuje naprężenia oraz siły, które zostaną wytworzone przez zadane obciążenie. Nasz most składa się z profili kwadratowych 14×14×0,8 ścianka. Jest to dość cienki profil, bo zależało nam na uzyskaniu jak najlżejszej konstrukcji. Dodatkowo wykonaliśmy stężenia. Nasz most musi być również bardzo sztywny. Są to rury kwadratowe 15 mm średnicy i ścianka 1 mm, natomiast krzyżówce i słupki kratownicy są wykonane z rurki też kwadratowej, ale już o średnicy 10 mm, ale też ścianki 1 mm. Ten most nie udałby się bez naszych sponsorów, a przede wszystkim bez firmy Metalfach, która pomogła nam w wykonaniu i prefabrykacji tego mostu. W ubiegłym tygodniu przez cały tydzień od rana do popołudnia jeździliśmy do Sokółki i razem z 2 profesjonalistami spawaliśmy tą konstrukcję. Zawsze mogliśmy liczyć na ich pomoc, na ich odpowiedź, ponieważ proces projektowania różni się trochę od procesu wykonawstwa i nawet w naszym projekcie na podstawie wykonywania i kolejnych kroków doszliśmy do zmiany pewnych rozwiązań, na przykład połączeń stężeń. Dodatkowo chcielibyśmy podziękować również firmie Promostal, a także naszej Politechnice i Wydziałowi Budownictwa i Nauk o Środowisku, gdzie ten most teraz składamy i wykonujemy i pracujemy.
Okay, so that's it. Thank you very much.
Thank you, Team Steel Rangers. Our third team is quite new to the Taltech grounds. At only just 18 years old, they are our only high school participating team this year. Please welcome to the stage Team Sillameistrid from Tallinna Technika Gymnasium.
Töötab, jah? Hi, my name is Rasmus. His name is Steffert. We are Team Sillameistrid, and we come from Tallinn's Technical High School, as Martin said. And yeah, so about us, we are from Estonia. We come from that school, yeah, and we are 12th graders, and we decided to participate in this competition just for some good experience and fun, and we are trying to do our best in this competition. The idea actually came from our school. We had a construction lecture in 11th grade, and our lecturer recommended us to take participate in Betoonitalent 2024, in which we got the first place in the strongest concrete, in making the strongest concrete. So our supervisor Jürgen advised us to also participate in BRICO 2024. So we decided to accept the challenge, and why not? So a little bit about the bridge. It's a little bit out of picture, but this is the 3D view. We ourselves didn't have some licenses and stuff to do it, but Jürgen helped us out a bit. The idea is actually ours, and we started designing in May, I think, and we had many different projects, but now 3 weeks ago our project, we throw it in the trash bag basically, and made a new one because the last one, it was too difficult to build by our own hands, and we really want to build it with our own hands, so we could gain a lot of experience from this. Yeah, that was our main point. And now the experience has been quite difficult, I would say. The bridge is, many parts are just hammered together because they won't go in. From the video, as you can see, they just, yeah. It's basically from bad cutting and bad cutting in the degrees or something. But we're trying to do our best without our supervisor Jürgen's help, so we could learn a lot from this and maybe get a better result next year. Here's a little video of how we built our bridge. It's not the same level as the other videos were, but yeah, I hope you enjoy.
And today we are in Nõmme forest. My name is Rasmus. I'm one of the members of this sillameistri team. And my hobbies are playing tennis, as you can see. And I also play airsoft. And in my free time, I like to test out some new business ideas, which might be a big success.
Hello, it's me, Carl, and I'm the member of the sillameistri team. And in the free time, I like to play football and hang out with my friends. And I like to party too.
Oh, hi, my name is Markus. I'm a runner, and I'm not a member of sillameistri team. Okay, actually I am. I like to run every day. I run, just run. And I live too in countryside. And yes, let's go to Tallinn now. Woo!
Six and a half hours later.
And now we are going to Tallinn. Laboratory of Mechanics and Metrology. Now we are here at sillameistri team BRICO. Wait, watch it.
Next year we will do a better introduction. Thank you for listening.
Thank you for this humoric approach to your presentation. And for last, we have a team closer to home. I would say with even a bit of a home field advantage. I welcome to the stage our representative from team inspired by Norte.
Well, thank you, Martin. I have to apologize for my team members since they are busy right now doing their engineering jobs and attending the courses, but I will give you a brief introduction about our team. So greetings to everyone. Our team name is Inspired by Norte, and this is our bridge. I will introduce our team members. We are the 5th year students from Tallinn. We study structural engineering and construction management, and everyone is employed as the structural technicians. Basically, it's more like junior structural engineers because we are doing some computations, but basically the drawings and modeling. And our goal for the competition is to achieve the ultimate precision of required carrying capacity. Thus, we try to come as close to the necessary limit, but try not to use big safety factors. And this is our first member, Martin Erik Johandi. This is Maria. Maria is an Ironman athlete. This is Marit. Marit likes motorcycles, and this is me. I'm advanced scuba diver. And we are grateful to our supervisor, Andres Vaar, who is a senior structural engineer at Norte. And he is one of the engineers that created the NFIT 282. This is where the inspiration came, and it weighs around 6,000 tons of steel. And as we were talking, that steel is green material, so NFIT uses green steel in their plants. And it's also participating in Tekla Beam Awards, so go check out and maybe vote for the project. But about our bridge, we started with sketching on a paper. I remade it in paint to give you a better picture of that. But this is the initial design, and then we started to adjusting it in AutoCAD. We painted, where's the red dot here? Which button?
In the middle.
In the middle. This, yeah, thank you. So we drew some boxes that were required in the rules of the competition. And then we did some other views, and as you can see, we tried different placement of the boxes here. And we came to a conclusion that this design is too complicated to construct because it's not on one plane. These ones are more similar, so we stick to them. And then we modeled the bridge in Tekla structures. The license was provided from Norte, where I came from. And this is how the model looked like. And we also paid attention to the views, so it would be aesthetic from the top as well as from the side view. So you can see those shapes here, those forms. In my opinion, they are great. So since I'm the architect of this one. And we did analysis in robot structural analysis software. We used 10 combinations. So we placed 750 kilos here. These values are in kilonewtons. And we started placing the possible positions of the plates. And we used safety factor of 1.05. For the dead load and buckling length was 1. And if you ask why is this 1, because we have a truss here, there are some coefficients like 0.9 and 0.6 or 7. This is because we have some different type of joints that are not in Estonian Eurocode. These are flattened ends, but the inspiration came from this picture where I saw the stress in the pipe with this plate here. So to make it more simple to produce, we decided to flatten the ends. So it would affect buckling length somehow, so we stick to factor of 1. And the second type of joints why we chose the buckling length of 1 are the socket joints. Basically, the pipes end somewhere here, and this bolt shall ideally not work for shear because of the tolerance of the holes. So these tubes are just under compression, and the socket is holding them in place, but it's not really transferring any load. And the sockets are located as close to the diagonal connections as possible because buckling is happening in the middle of the bar, so we try to reduce the detrimental effect of the socket because it's really loose when it's not when the load is not on the bridge. And you can see here are some of more critical elements. And we tried to optimize as much as we can, so we used really thin profiles. We used round hollow sections, and the diameters are 16 and 18 millimeters. So these bars are 18 millimeters, and the rest, compressed diagonals, are 16 millimeters. And thus we achieved really light weight of the bridge, which was one of the main goals for this competition for us. And we tried to reduce the thickness of base plates, and as you can see, we have some openings in them, and we performed ideostatic analysis for the plates, because ideally there shouldn't be any momentum on the plates, but in case if it happens, we try to predict some kind of moments that can happen there. And yeah, here are some sections that we used. There was round hole sections, and pulled diagonals we used just 6 millimeter diameter rods. Well, good luck for you.
Good luck to you as well, team inspired by Norte, and thank you for your presentation. And with that, we wrap up our opening ceremony. I wish you all of the best luck, and may the best bridge win. Meil on kaalud, siis seal koha peal panete kokku ära. Kokku panete sinna kaotakse? Jah. Ja, kokku. No siis mõtled, state forward. So you have till 11:30 to get to the